we are going to look at the motion under the influence of gravity. That means under the gravitational influence when a body is thrown vertically up. So here you must be clear that body thrown up is different from body thrown vertically up. So whenever it is thrown vertically up, it exactly going in a straight lined path along y direction. Unlike that, if at all you are throwing up in the sense, even a projectile motion it can have. That means it can move y-axis as well as along x-axis. That is a two-dimensional motion. But here we are keen about the vertically up in the sense a straight lined motion. So along y direction. So whenever it is moving against the gravity, the gravitational parameters come into picture. That means acceleration will be under the influence of gravity. In such cases, if at all I throw a body in upward direction from the ground, when a body is thrown in upward direction from the ground, it is going to certain height. It is going to certain height. So a body is thrown with an initial velocity u. When it reaches to a point here, its final velocity becomes 0. Then it will be coming down. It will be coming down and reaches the ground. So here initial velocity while coming down is 0 and the final velocity on reaching the ground will be v, let us suppose. So in this case, the initial velocity with which a body is thrown up is equal to the velocity with which it is striking back the ground. So how I can prove that the velocity at the time when it is thrown equal to the velocity when it strikes the ground, that can be derived in this way. Here, whenever a body is thrown up, it is going up then coming back, meaning that the displacement is 0. Here s is equal to 0 and this is the initial velocity, u is the initial velocity and v is the final velocity, v is the final velocity. Displacement is this, and what is the acceleration? Acceleration is nothing but at the time of beginning. So acceleration should be always taken at the time of beginning. So minus g is the acceleration here, plus g is the acceleration here. Therefore a is equal to minus g. Then the equation what I can use is using v square minus u square equal to 2as. Here v square minus u square is equal to minus 2g into 0. Displacement is 0. Therefore v square is equal to u square, that is v is equal to plus or minus u. That means the final velocity on striking the ground, this velocity I am taking, this is the velocity at the maximum point, but the total incident I have to take into consideration. When I take the total incident into the consideration, the final velocity is going to be this, initial velocity is going to be this. Therefore, the velocity with which it strikes the ground is equal to the velocity with which it is thrown up. Therefore, final velocity equal to initial velocity. This is one consideration you have to make. That means whenever a body is thrown up with some velocity, on striking the ground, after going to a maximum height, then it will come back and then strikes the ground. So the velocity at which it is thrown up is equal to the velocity with which it is striking the ground. This is how you can prove this. This is the first incidence of the vertical motion of a body. So when a body is thrown from the ground, reaching back to the ground with the same velocity. So this is how you can prove this.